Hi there. I hope everybody is doing great. Here I will be presenting the solution for additional mathematics 0606 paper 1, and this is from May-June 2023 exam. Some students say that this paper is difficult. Some say that this paper is different in style comparing to the previous past papers. Well, we shall see. Now, first thing first, this solution was made before the official mark scheme was published by Cambridge. So it is recommended that you try to solve this paper by yourself as well. So here we go. Number 1, the diagram shows the graph of this function. Find the values of the constants A, B, and C. A is the amplitude of the function. B is the periodicity factor, and C is the vertical translation. So, because this is no longer the principal axis, as you can see, the horizontal center, for explanation's sake, of this function has been moved. And this is how we find the shifted principal axis. We find the maximum value, that one there, 2, and we find the minimum value. We add them and we divide them by 2. Therefore, this is now the principal axis. So C is equal to -2. Knowing that the principal axis has been shifted to here, then we can find the maximum displacement, aka the amplitude. So remember, A, or amplitude, is always positive. Next, the period. If you look at this given curve, here we have one full length from minus 480 degrees to 480 degrees. So this is one full cycle, which is equal to 960. Okay, so the period 960 is equal to 360 divided by B. This is what we're after. Therefore, B is equal to 360 degrees over 960 degrees. That's equal to 3/8. Number 2, no calculator question. We are asked to solve this equation, giving your answers in this form, where A and B are integers. Okay, let's do it. Let's arrange all terms to one side and leave the other side 0. And we are asked to solve, meaning find the unknown variables, in this case, x. Here I use quadratic formula. This is A, this is B, and this is C. Input all of these coefficient into quadratic formula, and you should get this expression. And we can simplify it up to here. Therefore, x is equal to 4 subtracted by 2 over 2 by 2 plus root 5, or x is equal to 4 plus 2 over 2 times 2 plus root 5. Solve both of these to get to this form. Therefore, these are the values of A and B. Next question, number 3, part A. The diagram shows the graph of y is equal to the absolute value of f of x, where f of x is a cubic polynomial. Find in factorized form the possible expression for f of x. Given the graph, there are two possible functions that we can have. We can have this function here, the one that goes from here down and up again and down, or the other functions start from down here, up, down again, and up. Yeah. Remember, this is an absolute value function, meaning the parts below the x-axis is reflected up here. This question gives us a clue. Here we are given zeros or x-intercept. So these are factors of f of x. Therefore, f of x is equal to x plus 2 from this one here, multiplied by x minus 1 from this intercept, multiplied by x minus 4 from this one. We are given another clue, 24, the y-intercept. And y-intercept is when x is equal to 0. So let's replace all of these x with 0. So we have 24 is equal to, let's use m to represent the unknown. M multiplied by 8. Therefore, m is equal to 3. So f of x is equal to 3 times all of these. And since this is positive 3, the graph goes like this from down to up. And another possible function is when we have negative. So negative 3 times all of these. And this is when the graph goes from up, down. So here it is. Here are the functions. Next, part B. Solve the inequality of the absolute value of 5x minus 2 is less than or equal to the absolute value of 4x plus 1. One way to do it is to sketch these two functions. So let's start with y is equal to 5x subtracted by 2. As usual, we find the y-intercept and we find the x-intercept. So this is the function. And since it is an absolute value function, we reflect this dashes line part to here. And we do the same thing to this function, this one here. Okay. So what we want is this section here, where the absolute value of 4x plus 1 is greater than the absolute value of 5x minus 2. So let's find these two intersection, right? So to find the intersection, let's equate both function, but taking off the modulus notation, and we shall get x is equal to 3. Yeah. And then we find the other intersection. To do that, we can multiply by -1, either this function or this function. The x value should be the same. Let's multiply -1 to this function, 4x plus 1, which becomes minus 4x minus 1, equate to 5x minus 2. And the answer is x is equal to 1 over 9. Therefore, the answer is 1 over 9 is less than x, and x is less than 3. Question 4. This is a circular measure question. In this question, all lengths are in centimeters, and all angles are in radians. Right, the diagram shows a circle with center O and radius R. The points A and B lie on the circumference of the circle such that the angle AOB is theta, and the length of the minor arc AB, this one here, minor arc AB is 12. The area of the minor sector AOB, this one here, is 57.6 centimeters square. Point C lies on the tangent to the circle. This is tangent to the circle at point A, such that OBC is a straight line. Part A. Find the values of R, the radius, and the angle theta. We need these two formula. A is equal to half R squared theta. This is the area of a sector. Yeah. In this case, this area here, area of a sector. And then L is the arc length. This one here, AB, which is equal to R theta. Now let's rewrite this into this expression. We have area is equal to half R times R theta. We know R theta, the arc length, which is 12, that's given there. So substitute 12 there. And we're given the area of the sector, which is 57.6. And we can find R. Yeah, the radius of the circle, which is 9.6 centimeters. What about theta? Knowing R, the radius, we can substitute this value into here or here in order to find theta, like so. So theta is equal to 1.25 radians. Next, part B. Find the area of the shaded region. Give your answer correct to 1 decimal place. The question says this is a tangent line. Tangent line, therefore, must be perpendicular to this radius. So that's the key information there. So we know 9.6, the radius, we know this angle. Therefore, we can find this opposite side of this angle, which is side AC, by using tangent. Yeah, so tangent theta is equal to opposite divided by adjacent. And then we can rewrite this expression by having AC as a subject. Yeah, so there you go. That is length AC, 28.892. Now let's find the area of the triangle, which is the base, the radius, multiplied by the height, yeah, which is AC, divided by 2. That gives us 138.7. So the area of the shaded region is equal to the area of the triangle subtracted by the area of the sector there, which is equal to 81.1 centimeter square. Next, question 5. Part A, find the exact solution. Exact means no decimal, basically, of this given equation. Now, let x is equal to p to the power of 1 over 3. So we have 6x subtracted by 5 over x subtracted by 13. That's equal to 0. And what we can do next is multiply both sides by x to get rid of this fraction. And that gives us 6x squared minus 5 minus 13x is equal to 0. Rearrange this, yeah, into this expression, and then we can factorize to find the two values of x. Okay. And remember, x is equal to p to the power of 1 over 3. So replace x with p to the power of 1 over 3 and solve for p to get the answer. Next, part B. Solve the equation to log. LG means log or log base 10 of 2x plus 5 subtracted by log x plus 2 is equal to 1, giving your answer in exact form, no decimal. Let's rewrite this given equation, having log in both sides. So 1 is equal to log 10. And then we can apply law of logarithms. Here we have subtraction of logs, and that becomes log of a quotient, and that's equal to log 10. Since both log has base 10, then we can just equate these two expressions. And then we cross multiply or multiply both sides by x plus 2 to get this quadratic equation. And then we can apply quadratic formula where a is equal to 4, b is equal to 10, c is equal to 5 to get this. Okay. And then we can solve for x. So there you go. Number 6. Given that cotangent square theta is equal to 1 over y plus 2, and secant theta is equal to x minus 4, find y in terms of x. Let's rewrite this. Since we want to find y, I rearrange the subject so that we have y plus 2 here, and that's equal to 1 over cotangent square theta. And cotangent square theta is just equal to 1 over tangent square theta. So we have y plus 2 is equal to tangent square theta. So let's stop here for the moment. Now let's use Pythagorean identity, where sine square theta plus cos square theta is equal to 1. And let's divide both sides by cos square theta. Why? Because we want tangent. Yeah, this is tangent. So we have sine square theta over cos square theta. That's just equal to tangent square theta. And plus cos square theta over cos square theta, that's just equal to 1. And that's equal to 1 over cos square theta, which is equal to secant square theta. So tangent square theta is equal to secant square theta subtracted by 1. So we can replace that tangent square theta with secant square theta subtracted by 1 there. And we can subtract both sides by 2 to get this expression. Simplify to get that expression. And we are told that secant theta is equal to x minus 4. So we have x minus 4. Since we have squared there, then we put power of 2 here. So we have x squared minus 8x plus 16 minus 4. And that's equal to x squared minus 8x plus 12. So there you go. Next, part B. Solve the equation square root of 3 cosecant 2, 5 plus 3 pi over 4 is equal to 2, given this condition. Give your answers in terms of pi. We divide both sides by root 3 to get that expression. And remember, cosecant is 1 over sine. Therefore, we can rewrite this expression as sine 2 pi plus 3 pi over 4 is equal to root 3 over 2 Yeah, so we flip this. So to find the angle, yeah, we do sine inverse of square root of 3 over 2. And remember, we want both negative angles and positive angles. Negative angle means the rotation is clockwise, and positive angles means the rotation is counterclockwise. So here are the list of possible angles. Yeah, remember, we want to fulfill this condition. So we just list all the possible angles first, yeah, that we think will in the end fit this condition, okay? And then we subtract both sides by 3 pi over 4, okay? So subtract each of these by 3 pi over 4, and then divide by 2 to get this expression. Now, based on the condition, we can only take these angles. So there you go. Therefore, phi is equal to all of these angles. Next, question 7a. Find the number of ways in which 14 people can be put into 4 groups containing 2, 3, 4, and 5 people. Let's begin with a group containing 2 people. So we have 14 combination 2 here. Okay. And next, since we have taken 2, the total number of people now is 12. So 12 combination 3, because we want to make a group containing 3 people. So the number of total people left is 9 now. Yeah, 12 minus 3 is 9. And we want to make a group containing 4 people. Okay, so 9 combination 4. And the total number of people left now is 9 subtracted by 4 is equal to 5. And we want to make a group containing 5 people. So 5 combination 5. And we multiply all of these because this is one set, contain 14 people. So we multiply. And this is the answer. If you start making a group with 5 people down to 2 people, you should get the same answer. Next, 7b, 6-digit numbers are to be formed using these digits. Each digit may be used only once in any 6-digit number. A 6-digit number must not start with zeros. So this is an important clue. Find how many 6-digit numbers can be formed if, okay, let's do B1. There are no further restriction. So 6-digit order matters, so it has to be permutation. I use counting principle here. So there are 6 digits. So 1, 2, 3, 4, 5, 6. For the first digit, we can choose out of 9 because the first digit cannot be 0. And from the second digit, we can put 0 back. So we can choose out of 9 digits. And then since we have taken 1, it becomes 8, 7, 6, 5. These are just the same as 9 permutation 5, by the way. So we just multiply all of these to get this answer. B2, find how many 6-digit numbers can be formed if the 6-digit number is divisible by 10. So the last digit has to be 0. So put 1 there. And since 1 has been taken out, which happened to be 0, and 0 cannot be put on the first digit, so we have 9, take away 1, 8, take away 1, 7, and so on. And then we multiply all of these. So this is the answer. And by the way, these are just the same as 9 permutation 5. Question B3. The 6-digit number is greater than 500,000 and even. Now remember, each digit may be used only one time. Okay. For the last digit, since this is even, we can choose from 0, 2, 4, 6, 8. So there are 5 options. Put it there. And for the first digit, and again, this must be greater than 500,000. So we can choose from 5, 6, 7, 8, 9. So there are 5 options. So we take one for the first digit. We take another one for the last digit. So we are left with 8 options. Yeah, because the total digit is 10. Take away 2 is 8. And then we take one for the second digit, then we are left with 7 total options for the third digit, and so on. We multiply all of these because this is one set to get this answer. So there you go. Number 8, it is given that f of x is equal to 2 ln 3x subtracted by 4. Given this condition, write down the least possible value of a. Well, this part here, the part in the bracket, cannot be 0. Therefore, the least possible value of a is 4/3. So x is greater than 4/3. Okay. Write down the range of f. Well, range means y value. Now, for the y value, can be 0, can be negative, can be positive. So y is an element of real numbers. Next, part C, it is given that the equation f of x is equal to f inverse of x. So that's power of -1. That means inverse has 2 solutions, meaning 2 intersections. And the question tells us we don't need to solve this. Okay, so we don't need to solve this, or we don't need to find the x. And then using your answer to part A, this part here, sketch. Sketch means not to scale. Sketch the graph of y is equal to f of x and the inverse on the axis below, stating the coordinates of the points where the graph meets the axis, or in other words, x and y intercept. We can find x-intercept first. Yeah, x-intercept of f of x, meaning y is equal to 0. So 2 ln 3x subtracted by 4 is equal to 0. We divide both sides by 2 to get this expression, and then change from log form into exponential form. Remember, ln is log base e, so that base is e. So e to the power of 0, put it there, is equal to 3x minus 4. E to the power of 0 is equal to 1. And then we can find x. Therefore, this is the coordinate of x-intercept. We don't have y-intercept of f of x because this is the least possible value of a. X must be bigger than this, so we don't have y-intercept. And we can find y-intercept of the inverse. We just change the x and y coordinates. So the y-intercept of f inverse of x is 0.05/3. Okay. We need to know the shape of log function. Yeah, this one here. Okay. So this dashed line shows us x is equal to 4/3. And this curve cannot touch this dashed line. Okay. And in the inverse, this x becomes y. So y is equal to 4/3. So this dashes line show us y is equal to 4/3. And the inverse of x curve cannot touch this line here. And don't forget, we put the intercepts. And we need to show the two intersection as well, like so. Okay, so there you go. Question 8D. It is given that g of x is equal to 2x subtracted by 3 for x is greater than or equal to 3. Find an expression for g of x. So this is composite function. We put function g inside function g. So we replace x, that x there, with 2x minus 3, like so. And we have this answer. Very straightforward. Okay, next, question 8D2. Hence. Hence means use the previous result. Solve the equation fg of g of x is equal to 4, giving your answer in exact form. And this is function f from the earlier part of question 8. F of x is equal to 2 ln 3x subtracted by 4. And we already found g of gx, which is 4x minus 9. So hence, we can put this expression into function f. Therefore, we have this expression. So this is the expression that we insert to function f. Okay, we can simplify this expression inside the bracket first to get this expression. And then we can divide both sides by 2 to get this expression. And then we can transform from log into exponential. Again, remember, ln, this is ln, ln is equal to log base e. So e squared is equal to 12x minus 31. And we can solve for x. And that is the answer. Question 9. We are given this diagram that shows part of the curve. Okay, this one here. And also the straight line. 3y is equal to 2x plus 6. And then we are asked to find the area of the shaded region, giving your answer in exact form. Okay, well, we need to find the intersection between the curve and the straight line. That one there, yeah. So we equate them, yeah. Of course, for the line, we need to divide both sides by 3. So we equate the y's to get this answer. Well, there are 2, but this is the relevant one. Yeah, this takes place over this side. So we just use this one here. X is equal to 5/2. And then we can find the bounded area between the curve and the line using integral. So area is equal to integral from 0, yeah, from 0 to 5/2 of the top function here. Yeah, so that's the top function, the curve, subtracted by the lower function, and because this function is at the bottom, yeah, which is the straight line. So we simplify this expression first into that expression. My apology, I forgot the x, yeah? I should have put the x there, okay? And then we can integrate. The integral of 1 is just x. The integral of minus 2/3x is just minus 1/3x squared. Now for this, yeah, we take 2 out, yeah, because 2 times 2 is 4, so we take 2 out. Now for this expression, if you take a look, that numerator come from the derivative of denominator. Therefore, we can apply ln. So this becomes ln of the absolute value of 2x plus 1. We put modulus notation because we cannot calculate ln of a negative number. So this is the integral of this. And we put the boundaries, or some people call it limit. Yeah, this is the lower boundaries, this is the upper boundaries. And then we substitute the upper boundaries first, followed by the lower boundary, like so. And then we calculate, and we get the answer, 4 units squared. Last question, number 10, part A. The first 3 terms of an arithmetic progression are given here, and x is not equal to minus 1 over 2. Part 1, show that the sum to n terms can be written in this form, where a and b are integers to be found. So this is the formula. This is given in the paper. So Sn means the sum of the first n terms. U1, sometimes a is used to symbolize the first term. Here I use U1 to symbolize the first term. This is given, which is 2x plus 1, the one there, the first term, 2x plus 1, plus n minus 1 multiplied by the common difference. We can find the common difference, which is the term after subtracted by the term before. I choose that term subtracted by that term. Or you can do the third term subtracted by the second term, up to you. So this is the expression for the common difference. Put it there. We can take out the common factor because 2x plus 1 is common to both terms. So we take 2x plus 1 out, and we end up with this expression. Therefore, a is equal to 3 and b is equal to negative 1. Next, given that the sum to n terms is this expression here, find the value of n. So this is also the sum to n terms. And that is also the expression of the sum to n terms. So we can equate these two like so. And we can multiply both sides by 2 to get rid of this fraction. And we end up with this quadratic equation. We can factorize and we can find n. We reject this. Therefore, n is equal to 37. Next question. Given also that the sum to n terms in part 2, this one here, is equal to this value. Find x. But now we know n, which is 37. So we substitute n with 37 to get this expression and equate this with 1017.5 to find x. Moving on to the next question, 10b. The first 3 terms of a geometric progressions are given here, where y is not equal to minus 1 over 2. Given that the nth term of the progression is equal to 4 times the n plus 2 term, find the possible value of y. So this is plural, yeah, meaning more than one value, giving your answers as fraction. Okay, this is the general formula to find a term of a geometric sequence or progression. And from this key information, un the nth term, is equal to 4 times un plus 2. Okay, un is equal to this, u1 times r to the power of n minus 1, and this is equal to 4 times u1 times r to the power of n plus 2 subtracted by 1. And here we apply law of indices to the r to the power of n minus 1. This is equal to r to the n over r. And here we have r to the power of n plus 1. And this becomes r to the n times r. And then we can cross u1 and r to the power of n to end up with this expression. And then we can find r, which is equal to plus minus 1 over 2. R is the common ratio, and this is equal to the term after divided by the term before. So here I choose the second term divided by the first term to get this expression. And we can equate this to plus minus 1 over 2. And we have y equal to minus 7 over 12, or y is equal to minus 5 over 12. Next question, 10C. The first 3 terms of a different geometric progression, so this is different to part B, are these. For 0 is less than theta, and theta is less than pi over 2. Find the values of theta for which the progression has a sum to infinity. And this is the formula for the sum to infinity with this condition. The absolute value of the common ratio is less than 1. Let's find the common ratio then, because we have to meet this condition. The common ratio r is equal to the term after divided by the term before. Here I choose the third term divided by the second term to get that expression. And let's use this condition. So the absolute value of 2 sine squared theta is less than 1. If we open this modulus notation or absolute value notation, we have 2 sine squared theta is less than 1, and minus 2 sine squared theta is less than 1. And we reject this, and we continue with this. Now here we have sine squared theta is less than 1 over 2. Yeah, we divide both sides by 2. And sine theta is less than plus minus 1 over root 2. Based on this condition, we only use the positive 1 over root 2. Yeah. So theta is less than sine inverse of 1 over root 2. Theta is less than pi over 4. Therefore, this is the values of theta. So there you go. I hope this presentation helped.